All right, so today we're going to talk about moving the functions that you were introduced to yesterday. So if you remember yesterday, we looked at the 7 basic functions, and we looked at, linear and quadratic aren't new ones. They're ones that you did last year. And then you saw the cubic function, the absolute value function, the root function, the exponential function, the reciprocal or the rational function, and then, if my memory is correct, am I forgetting one? Did I say exponential? Root function? I think I said them all. Anyways, now what we're going to do is just apply things that you learn in grade 10 to how I can move a function and really utilize that knowledge to move any of the functions that we've talked about, especially the new ones. So when we say we're translating, as the title shows, it means that we're moving a function left, right, or up or down. So if you look at the quadratic function, which is what we'll look at first, you may have noticed yesterday I talked about the original function. So here's just x squared. There's nothing going on. It's not opening up or down, moved left or right. Okay, there's no transformations on it. It's just what we call the parent function. All right. So when we looked at, say, a quadratic, you may remember we used the letter A in front. And maybe you remembered that when A was positive or bigger than 0, right, then the parabola, we said it opens up. Okay? And if A was negative, then the parabola opens down. Okay? So we're going to get back to this idea when we talk about reflecting. All right? Now, you may also remember from the general form of a quadratic something that looks like this. All right? And this type of quadratic, if you remember, is in vertex form. So hopefully this may have triggered a memory, right, where a quadratic in vertex form gives me the coordinate of the vertex. All right. So obviously this entry is the x value, and this one here is the y value. Now x, obviously, when you think about the two-dimensional plane and the xy grid, x deals with left or right, and the y value is up or down. All right. So you may have recalled, like, when we in grade 10, when you're introduced to moving quadratics, like, the vertex doesn't always stay at the origin when we talk about the parent function. It can move around. All right. So let's look at a kind of simple example here. Where here I have the original function, or this one we call the parent function. Okay. And then we're going to apply some transformations to it. So it's been moved. All right. So now again, when we think about this, generally, like, if you know it's in vertex form, so we know where the vertex is, right? The vertex here is -3 and -4. All right. So that means that, like, when we think about writing the vertex compared to the original function, what we're doing here is we've moved the graph of f of x 3 to the left and 4 down. All right. Now, sometimes in the kind of like the math classes that we would have had it in person, right? Generally, what we would do is we would graph f of x first, right? I always graph the base function. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it's symmetrical. So it's going to be here, right? So here is my graph of f of x. Now, again, when you use Desmos, I mean, literally you type in the equation and the graph shows up immediately. So it's not that you entirely need to draw these graphs by hand, all the time. But anyways, so like when we look here, right, I have like these dots here that I have, these are my key points, right? So like I know the vertex is -3, -4, which is me taking this point and moving it 3 to the left, 1, 2, 3, and then 4 down, 1, 2, 3, 4, right? And then same thing, I'm going to take this pointer right here and move it 3 to the left, 1, 2, 3, and then 4 down, 1, 2, 3, 4. Now I know it's going to be the same on this side because a parabola is symmetrical, okay, from its vertex. So again, I'll take this point, I'm going to go 3 to the left, 1, 2, 3, and 4 down, 1, 2, 3, 4. And then this point will be here. And then really, I mean, that's enough. Like, I mean, I know there's some more points up here, but we know what a parabola looks like. So we don't really need to worry about it. And then now I'm just going to draw my parabola here. Okay, and I'm just going to call this g of x. Okay. And again, essentially, what have I done? I've taken this point, right? It's gone 4 down and 3 to the left. Right, this point, 4 down and 3 to the left. Okay? This is -4. This is -3. So again, you've done this in grade 10, really, when you had to, like, you're introduced to the different forms of quadratics and how I can have parabolas that are thinner or wider and the vertexes that can be moved away from the origin. So hopefully that wasn't too bad. Now what we're going to do is we're going to do the same thing, but we're going to do it to a root function. Okay? So now we're essentially doing the same thing, just we have to draw the function, or we're not using a quadratic. Let's just say that. Okay? So again, just to remind us, right? So this here, this is the parent function, okay, with no transformations. G of x is the one that is, we're moving the parent function. Okay? So the parent function, we know is a root. Now, what are the transformations? Well, think about it. It's the exact same thing as we talked about here. When we looked at a quadratic, right? See how the vertex is, like when it's inside of the bracket that's squared. What happens to the x value? It's the opposite, okay? So if it's +3 in here, I'm actually moving it in -3. And then the sign for the number that's, plus or minus after the function, it's just whatever the sign is. So here it's -4, so I go 4 down. The same logic applies here. So if I look, if we look in here, what is this? This is x plus 3. Okay? So that means I'm going to move not 3 in the positive direction, but 3 in the negative. Okay? Or 3 left. And then this -4 here. Okay, notice how the -4 isn't under the root. So this is just going to be 4 down. All right? And it's going to be it's good practice that when you're given an equation, when you're given a function, you may be asked to just talk about the transformations, just so that you understand kind of how things are moving. All right? So now what we're going to do when we graph it, and again, most of your work is going to be on Desmos, so you don't have to really worry about graphing by hand all the time, but I just want to show you kind of what is going on here. Okay? So again, we know the root function starts at 0. 0 squared is 0. 1 squared, square root of 1 is 1. Square root of 4 is 2. And the square root of 9 is 3. All right, and I'll just write those down. And again, once you do enough of these, then you know that these are the key points that I'm using. And if you noticed on the Desmos activity from yesterday, when we used when we use all the values like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, the ones that weren't perfect squares were kind of ugly. Okay, so here's the graph of f of x. Okay, now, so what am I doing? Well, the graph of g of x is just this graph, but I'm just moving it 3 left and 4 down. So this point is going to go 1, 2, 3 to the left and 4 down. 1, 2, 3, 4. So I'll put a dot there. This point 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, and 4. All right. So notice just how this function starts at 0. Like notice there's no arrow here because this thing stops. So same thing here. This is going to start here and move this way. I'm going to put the arrow here. And I'll call this g of x. Okay. Now, one thing I just want to kind of talk about, since we're here, is domain and range, right? So if I look at f of x, okay, the original, we know that the domain for a root function, okay, x is an element of R, but x has to be bigger than or equal to 0, all right? I can't have a negative under the root. And the range is similar, right? Y is an element of R, y can be any real number, but y has to be bigger than or equal to 0. When I move the function, right, so it's been moved 3 left, 4 down, guess what happens? The domain and range change, right? So if I have g of x, well, what's the domain of g of x? Well, where does it start? Right, it starts right here. So what's this value? Well, this is x equals -3. So the domain is going to be x is a real number, but x has got to be bigger than or equal to -3. All right. And then range, we'll check it out. Where does the y value start, or what's the lowest y value? Well, here it's y equals -4. Okay, it starts at a y value of -4 and gets bigger. Okay, it doesn't exist below this. So we'll say y is a real number. Y has got to be bigger than or equal to -4. Okay, so as we move these functions, and we will have to kind of talk about the domain and range and how they are affected by it. But again, with the pictures of the graphs, really domain and range is a lot easier than if you were just, say, given an equation and you had to, kind of figure it out for yourself. All right, here's just a quick one where we're going to describe the transformations. Okay, so we have 3 examples, 3 different functions. So what I'm going to ask you to do as we work through this is first we'll just say what the function is, what kind of function it is, and then list the transformations. So if you look at this one is the exponent, the highest exponent is a cube. So that means that this one is what we call the cubic function. Okay. And then if we look at the transformations, right? This one is going to be left, right. And this one is going to be up, down. So here what we're going to have is 7. So see how its plus is going to be in the opposite. So 7 left and 4 up. All right. This one, notice here, my exponent, see how my exponent is where the variable is, right? Like here, the exponent is a number and I have an x in the normal spot. Here, this one's a little weird, right? An exponential has the variable in the exponent. So I kind of obviously gave that one away, but most of you probably, I think, figure that out, right? This is exponential. Okay. And then if I look again, right, this part, right, is going to tell me left or right, and this is going to tell me up or down. So when you're dealing with different functions, it's going to affect, notice how like the left or right is always with the x. So here, where's the x? The x is in a bracket, that's cubed. Here, the x is in the exponent. So it's like a different, in a much significantly different area than what we're used to. But again, it's x minus 1. So it's the opposite. So I'm going to go 1 to the right. And then this is plus 1, so it's just going to be 1 up. All right. And then this one here, my the x value is in the denominator of a fraction. So this one is what we call the reciprocal function or the rational function, depending on what we talked about. Okay, so this one is the reciprocal, okay, or the rational function. And then again, if it's plus, and I'll reiterate this again. See how like the shift left or right is always with the x. So if the x is in the denominator, then this plus 4, like this whole thing is in the denominator. So it's not going to be 4 in the positive direction. It's going to be 4 in the negative. So it's going to be 4 left. And then minus 10 is 10 down. All right. So again, the more like you'll get the hang of this as we kind of go through this, and you'll have enough Desmos practice where I think you'll pick up on these relatively quickly. Okay. Next, what we're going to talk about is reflections. Okay. So this is where I was saying that in grade 10, when we deal with a parabola, right, I have the a value. So if a is positive, the parabola opens up. If a is negative, the parabola opens down. Okay. And then here, when I just graph this down here, you kind of have the idea, right? So like here, right, this opens up. Okay, pretty basic, right? You see this graph, this parabola opens up. Okay, if it opens down, okay, it's like this. Okay, now what we generally say is that like the parabola that opens up, when it opens down, it's being reflected over the x-axis. So we're just using a new kind of term, a new phrase to talk about, like, you know, for a parabola, we always talked about opening up and opening down, but not all functions have the same shape as a parabola, which means that we can't really describe it as opening up. You know what I'm saying? Hopefully. So this type of opening up and to opening down, we're going to call a reflection over the x-axis. So hopefully that makes sense. And we'll do just a couple of examples where we want to show that. Okay. So here is a graph of f of x. Okay. I just drew it myself. And we want to reflect f of x over the x-axis. All right. So what I'm going to do, just to kind of illustrate this point, is if we write out all the coordinates of f of x, so I have a, which is -6 and 3. You got b, which is -4 and -3. C, which is 3 and -1. And D, which is 8 and -1. All right. So if these points were to flip or reflect over the x-axis, well, which point, like which coordinate would have to change? Okay. Well, think about it. For me to reflect, like for this point to reflect over the x-axis, okay, so if it's going to reflect over here, right, the x value stays the same, but the y value has to be the opposite sign, has to be switched. Okay, so that what that means, if I erase this, is that if I'm just going to put these dots here, and then I'm going to move them. Okay. So this point, the distance from A to the x-axis is 3. So it's going to be now 3 down here. Okay. This point, the distance from this point to the x-axis is 3, but it's in a negative. So now it's going to flip to the positive. This point here has a distance from the x-axis of 1. All right. So if it's going to flip, it's going to flip 1 up here. And then this point here is the same deal. It's the distance from this point to the x-axis is 1, so it's going to flip 1 away from the x-axis on the other side. And then what I can do is I'm going to draw myself a nice graph. And I'm just going to label these points just to illustrate this point. Okay, so we have A, B, C, D, E, F, G, and H. So E is going to be, well, here, let's just write it here. So E, it's just going to be the same X value, but the Y value is going to just be opposite. So F is going to be -4 and 3. It's going to be the opposite of B. And then C, oops, sorry, not C. G is going to be 3 and 1. And H is going to be 8 and 1. Because again, when you think about moving on a grid, how do I move up and down? Okay, that's the Y value of the coordinate. So if I'm going to reflect over the x-axis, then that means the Y value has to be opposite. And when you look at this graph, hopefully, right, like you see that reflection, right? If this is the line, right, you can see that the red one is and the blue one are reflected over the x-axis. Okay. And again, here what we talk about is just, I kind of just said this, to flip over the x-axis means to change the y coordinate to its opposite sign. Okay, so if I have, in general, x and y, then that reflection is just, the x stays the same, the y is negative. Okay, now here I just used our new notation just so that you're comfortable with it, right? If I change y to f of x, then it's the same thing, negative f of x. All right. And here I just made a little note. If we type this in decimals, it'll flip automatically. So again, that's why understanding the little nuances in the notation really helps you when you're graphing on decimals, because if you type in the correct negative sign, it'll flip it right away. Whereas, if you notice, when we did this, flipping this took a while, right? Flipping, when we did these ones, right? This one took, or not this one, this one, right? It took a little bit of time. Whereas if you type it in decimals, it's almost exactly the same. Or sorry, I was just rambling. Not exactly the same. It's, it's much, much more efficient, more quick to finish. All right, last example. I think, yeah, this is the last example. So now what we're going to do is we want to reflect over the y-axis. So if you notice, I've highlighted the y-axis here, and I think I have a very similar. Is it the same one? It is the same one, I think. Right? Yeah. So we're just flipping this one over the y-axis. So notice again, if I'm going to, and I'll just do the same kind of exercise, I'm going to color these points. And then I'm going to move them. So if I want to move this point, right, I'm moving it this way, okay? So what I want to do is say, well, how far, what's the distance from this point to the y-axis? Well, it's 1, 2, 3, 4, 5, 6. So that means that it's going to be 6 on the other side. 1, 2, 3, 4, 5, 6. And same thing here, right? What's the distance from this point to the y-axis? Well, it's 1, 2, 3, 4. So that means it's going to be 1, 2, 3, 4 across. Now these 2 points are on the positive kind of x-axis, which means that they're going to flip onto the negative. And same thing, this point is 1, 2, 3 units from the y-axis, so it's going to be 1, 2, 3 units again. And this point is 1, 2, 3, 4, 5, 6, 7, 8 units from the y-axis, so it's going to be another 8 on the other side. So 1, 2, 3, 4, 5, 6, 7, 8. And then again, we just draw ourselves a nice, pretty little graph. And again, I'm going to call this E, F, G, and H. And again, if we were to look at these coordinates, right? So A, B, C, D, E. So E is going to have the same y value, but the x is going to be switched. So it's going to be 6, 3. Okay? Oh, wait, 1 second. Sorry. For me to do that, 1 sec. Let me just change these. So this is going to be E, F, G, and H. All right? F is going to be 4 and negative 3. C is going to be negative 3 and negative 1. And we'll see. I feel like I made that same mistake before, right? I just copied the C. So it's not C. It is G. And then H is going to be negative 8 and negative 1. So again, when you look at the coordinates, and I'll just highlight this here with my highlighter. Right, notice like these points are now becoming opposite. Because again, the x value is how I move it left or right. So when I'm moving left to right, it has to be the x coordinate that's going to make me move these points. And I think I have this written down here. Okay, to flip over the y-axis means to change the x values to their opposite side. So again, if I have the general point xy, then that means that the x value is negative. And then if I use function notation, check it out. See how, look how it's different, right? If the x is negative, then that means in function notation, the x is also negative. So that will give us a reflection over the y-axis. All right. So hopefully that wasn't too bad. And check out the news feed for all of the work for today. And like I said, a lot of it, when you're doing the activities on Desmos, you should be able to pick up on the nuances of just like left, right, up, and down, hopefully relatively easily. Okay. And again, hopefully you're not too scared of graphing, but graphing with Desmos really is a tool that is for your advantage in learning all this stuff. Okay, so we'll see you later, and have a good one.